Now that we have enabled monitor mode on our wireless interface, we are able to capture all the Wi-Fi packets sent within our range. Even if the packet is not directed to our computer, even if we're not connected to the target network, and even without knowing the key or the password to the target network. So all we need right now is a program that can capture these packets for us. The program that we're going to use is called AeroDumpNG. It's part of the AirCrack-NG suite, and it's a packet sniffer, so it's basically a program designed to capture packets while you're in monitor mode. So it'll allow us to see all the wireless networks around us and show us detailed information about its MAC address, its channel, its encryption, the clients connected to this network, and so on. So let me show you how we're going to use it. First of all, you need to enable monitor mode on your wireless adapter as shown in the previous lectures. So if I go to my Kali machine and run iwconfig to list all the wireless devices on this computer, you'll see that I have an interface called Mon0, and this interface is in monitor mode. Now, depending on the way that you enabled monitor mode, this can be called LAN 0, it can be called LAN 0 Mon, it doesn't really matter. You just want to make sure you enable monitor mode using one of the methods shown before, and then use the name of the adapter that is in monitor mode when you run AeroDumpNG. Now to run AeroDumpNG, we're just going to type the name of the program, which is AeroDumpNG, followed by the name of my wireless adapter in monitor mode, which is Mon0, as you can see in here. So the command is very simple. We're typing the program name, which is AeroDumpNG, followed by the name of my interface in monitor mode. If I hit enter, you'll see it'll start working, discovering all the wireless networks around me and displaying useful information about them. This program will continue working unless you quit it, and to quit this program, you have to press Ctrl+C from your keyboard. You can actually use Ctrl+C to quit any running program in your terminal. Now that we stopped the program, let's analyze the output so we understand what it's showing us. So first of all, if we look at this column, the ESSID column, it should be a little bit familiar to you. And basically, this shows us the names of the wireless networks around us. So if I just go to my Mac machine and look for wireless networks, you'll see the same names that we see in here displayed under the ESSID. Now all of the other columns show us more information about the network name that you see in here, and this information will actually be very useful to us as we go through the course. The first column, the BSSID, shows us the MAC address of the target network. Next, we have the PWR, so this is the signal strength or the power of the network. Now, the higher the number, the better signal we have. So, for example, the network with the best signal right here is this one. Next, we have the beacons. These are frames sent by the network in order to broadcast its existence. So every network, even if it's set to be hidden, always sends these type of frames, basically broadcasting its existence and telling all the wireless devices around it that I exist, I have this BSSID, I work on this channel, I use this encryption, and my name is this. Next, we have the number of data packets or data frames, and these are the useful packets that we'll talk about later on once we get to the cracking section. This column represents the number of data packets that we collected in the past 10 seconds. Next, we have the channel, which is the channel that the network works on. So for example, this network right here, the test AP, works on channel 6. This network works on channel 1, and so on. Next, we have the maximum speed supported by the network. The encryption is a very important column, and it shows us the encryption used by the network. So we can see that the test AP network is using WPA. We can see we have a network that uses web. We can see this network right here is an open network, so it doesn't use encryption. We don't even need a password to connect to it. And we can see we have a WPA2 network right here. Cipher is the cipher used in the network. So we can see here we have CCMP, we have web, and we have CCMP again here. Auth is the authentication used on that network. And in here we can see it's PSK, pre-shared key, and MGT for this network. Now don't worry about the ink, the cipher, and the auth. We will talk about breaking into all these networks into web, WPA, and WPA2 in the gaining access section. And finally, you can see we have the ESSID section, which shows the name of the network. So this is what you see when you look for networks in your network manager. So that's it for this lecture. I just wanted to give you a quick look on how to discover all the networks around us using AeroDump-NG. Don't worry about AeroDump-NG too much now. We're going to be using it a lot in the next lectures, and you'll get very comfortable with using it as we go through the course. In this lecture, I'd like to talk about Wi-Fi bands. The band of a network defines what frequency it can use to broadcast the signal. This means it also defines the frequency that the clients or the computers need to be able to support and use in order to be able to connect to this network. The two main frequencies used in Wi-Fi networks are 2.4 and 5 GHz. Now, previously, when we used AeroDump-NG, we were only sniffing on the 2.4 GHz frequency. You can see, first of all, my wireless adapter is in monitor mode, Mon 0 in here. So if I just do AeroDump-NG Mon 0, you'll see that I can get the wireless networks around me. But you might have noticed that you won't actually see all the networks around you when you run AeroDump-NG. I'm going to Control-C this, and if I go here to my normal host machine, and it actually has a built-in wireless adapter, so it's not as strong as my alpha adapter, but if I look for networks, you'll see I actually have much more networks in here. And mainly I have networks ending here in the name by 5G. Now, the network doesn't have to necessarily end in 5G, but here in Ireland, if a network broadcasts over 5 GHz, the service provider adds 5G to the network name. But we also have other networks broadcasting over 5G that don't end in 5G. But basically the main point that I want to talk about is I'm not able to see all the networks around me in here in AeroDump-NG. And the reason for this is because AeroDump-NG is only sniffing on 2.4 GHz frequency. So if you do this and you don't see all the networks around you, or if you're sniffing on your own network, but you don't see all the clients in your network, it's possible that your router is broadcasting over two bands, over 2.4 and 5 GHz. And if you're not seeing the router at all, if you're not seeing the network at all, like what's happening here for me, then the router is probably just broadcasting over 5 GHz. Now, this doesn't mean that your wireless adapter is not good. It just literally means that this adapter is not able to see 5 GHz frequency. It's just outside of its limit, outside of its reach. The main problem with 5 GHz is that there are a lot of wireless adapters that can see it and can communicate with it, but not many of them support monitor mode and packet injection. So you might see me and other people recommending wireless adapters like Alpha AWUS 036NHA. This is my most favorite wireless adapter. I use it all the time, even now. But the problem with that adapter is it doesn't pick up 5 GHz frequency. So it doesn't mean that that adapter is bad, it just means that it can't see 5 GHz frequency. Like I said, there aren't many wireless adapters that support 5 GHz, but I have an adapter here. It's Alpha AWUS036ACH, and this adapter supports both 2.4 GHz and 5 GHz frequencies. It's not as good as the Alpha, but it does the job. Now, if you want more information about wireless adapters, check out the link in the resources. I'm not going to talk a lot about what wireless adapters do, but in this lecture, I want to show you how to sniff and discover 5 GHz frequency networks, and then so that you can use all the attacks that you've learned in my other lecture and in my previous videos with 5 GHz networks. So, the adapter that I'm using right now supports 5 GHz, but as you can see, I still can't pick up these networks. That's because I need to specifically tell AeroDumpNG that I want you to listen on 5 GHz frequencies and 5 GHz channels. To do that, all we have to do is just do AeroDumpNG, like we always do. And then we're going to use a new argument that we haven't seen before, and this argument is called band. And we're going to tell it that I want you to sniff on band A, and that's the band that supports 5 GHz frequency. And then I'm just going to give it the name of my wireless adapter in monitor mode, which is Mon0. So the command is very simple. It's very similar to what we've used before. And all we have to do is just type in AeroDumpNG, followed by the band. And the band that we want to use is A. And we're following that with our wireless interface. So I'm going to hit enter. And as you can see, as soon as we hit this, I'm actually just going to do Control-C now because you can see the results. You can see that we got much more networks right now. And we have the 5 GHz network. So we have this network and this network that we weren't able to see. We have the Jameson Whiskey network as well. And basically we're able to capture all the networks that use the 5 GHz frequency. Now what you can also do, let me clear the screen. You can specify multiple bands using the band argument. So again, using the same command, instead of just saying band A, we can do band ABG. And what this will do is it'll tell AeroDumpNG to capture data on both 2.4 and 5 GHz frequencies at the same time. So let me show you. So as you can see right here, we're capturing some 2.4 GHz networks and we're capturing 5 GHz networks as well at the same time. And we'll also be able to discover clients connecting to both bands. The only problem with using AeroDump like this is, first of all, you need a powerful wireless adapter to do this. Also, it'll be slightly slower than only sniffing on one band, because when you're sniffing on two bands, you have a lot of channels that AeroDumpNG has to hop on all of them and discover clients and networks broadcasting on these channels. So, if you want quicker results, then you're better off just specifying the band A when you want to sniff on 5 GHz frequencies and just not specify the band when sniffing on 2.4. But as you can see, you can just run the command like so with band ABG, and this way you'll be able to capture data sent over 2.4 and 5 GHz frequencies. Also keep in mind, in order to sniff data on 5 GHz frequency, like I said, your wireless adapter needs to be able to support this band. So simply adding the band argument will not work unless your wireless adapter can support and can sniff data on this band. One more thing that I want to note, I've actually said this before, if you run AeroDumpNG against a network and you see some devices missing, then there is a high chance that these devices are connected over 5 GHz. So again, use the band A and then you should be able to see these devices. In the last lecture, we've seen how to use AeroDumpNG to list all the networks around us and display useful information about them. Usually, we do this in order to see our target network, see the signal strength, see how far we are from it, and then start targeting this target network. Now, in this example, I'm going to assume that my target network is this one right here. This is actually the network that my host machine is connected to. And now that I have my target network and I have some basic information about it, let's see how we can run AeroDumpNG against this network only, not against all networks. And this way, we'll be able to gather more information about it. So, to do this, first of all, I'm going to have to write the name of my program, which is AeroDumpNG. Then, I'm going to specify a specific BSS ID or a specific MAC address for AeroDumpNG to sniff data from. So my target network has a BSS ID of this. We can see it here under the BSS ID. So I'm going to copy it. And then I'm going to do --BSS ID. And I'm going to give it the BSS ID that I just copied. Next, I'm going to specify a channel for AeroDumpNG to sniff on. Again, if we look under the channel column in here, we can see my target network is on channel 2. So I'm going to do --channel 2. So now we're telling AeroDumpNG that I want you to sniff data on channel 2 and only from a network that has this BSS ID. I'm also going to tell AeroDumpNG that I want you to store all the data that you're gonna gather for me in a file. So I'm gonna say --write, and then I'm gonna type a file name, and let's call this test. And at the end, as usual, I need to give it the name of my wireless adapter in monitor mode, which is mon0 in my case. So, very simple command. Let's go over it one more time. We're doing AeroDumpNG, that's the name of the program that I want to use. I'm telling it that I only want you to sniff data from a specific BSS ID. Then I'm giving it the BSS ID of my target. Then I'm telling it I want you to only sniff data from a specific channel. And I'm giving it the channel that I wanted to sniff data from. Again, we can get it from here, it's number 2. Finally, I'm telling it that I want you to write all the data that you're going to capture in a file that we're going to call it test. And then I'm giving it my wireless adapter in monitor mode, which is mon0. Now I'm going to hit enter. And as you can see, unlike the last time, AeroDumpNG is only showing me one network in here. This is the network that I wanted it to sniff data on. And we can also see we have a completely new section right now. So when I ran AeroDumpNG in the previous lecture, you seen I only had the networks in here and I had nothing here at the bottom. But now you can see we have more entries in here at the second section of AeroDumpNG. And basically anything that you see here in the second section, these are the clients or the devices connected to this network. So right now we can see this network has 3 devices connected to it, and you can see the MAC addresses of these devices under the station. So you can see all of these devices are connected to the same network. So the BSS ID is still the same. This is the MAC address of the network, and under the station we have the different clients or different devices connected to this network. We can also see the power, so this is the signal strength of each of these devices. We can see the speed, we can see the amount of data lost, we can see the amount of frames or packets that we have captured, and we can see if any of these devices are still probing for networks. So sometimes when you run AeroDumpNG against all networks, you'd still see this section and you'd see that some devices are not connected and they're literally trying or looking for networks. So you'd see the name of the networks that they're looking for under the probe. Now, if I hit Ctrl+C, AeroDumpNG will quit, it'll stop working. but I should have new files in my current working directory that contain the data that we just captured. Because remember, when we ran the command, we used the right option in here to store the data in a file called test. So if I just do ls to list all the files in my current working directory, you can see I have 4 files. All of them start with test, but they all have different extensions. So we have a CSV, we have a netxml, we have a cap, and we have a Kismet CSV. Now also notice that aerodump-ng automatically appended -01 to each of these files. So in the future, when you go and try to use the capture file, make sure you append -01 to the file name that you specify in the command. Now, the main file that we're going to be using is the cap file. Again, this file contains the data that we captured during the period that aerodump-ng was working on in here. And basically, this file should contain everything that was sent to and from my target network. So it should contain URLs, chat messages, usernames, passwords, or anything that any of these devices did on the internet. Because anything that they have to do will have to be sent to the router, as we've seen before. The only problem is, if you look at the encryption in here, you can see that my target network uses WPA2 encryption. So all of the data sent between the router and the clients is encrypted. So let me show you what I mean. I'm going to use a tool called Wireshark to analyze the data. And don't worry about how to use Wireshark. We will talk about it in details later on. Right now, I just want to make sure that you understand the idea that now we're able to capture all these packets. The only problem is these packets are encrypted. So I'm going to do Wireshark to run Wireshark. And then I'm going to open my capture file. So I'm going to go to File, Open, and it's already in my root directory. So I'm just going to scroll down and select my test1 cap. I'm going to open it, and I'll just put this in full screen. And as you can see, if we click on any of these packets, you can see we really have no useful data. You can see everything looks like gibberish, and we can't read anything, even though these packets might contain usernames, passwords, or URLs. The only useful thing that we can see here is the device manufacturer. So we know one of the devices connected to the network that has this specific MAC address. So it's the one that ends with E8. And if we go up, we can see that it's this specific device. We know now it is an Apple device. So it could be an Apple computer, it could be an iPhone or an iPad. And this is actually my MacBook computer that is the host machine. Again, we can see we also have a device that's using a Huawei chipset. So this can be a phone, or it could be the router. And if you look at the MAC address here and compare it to the MAC addresses that we have here, you can see that this is actually under the BSSID. So this is the MAC address of the router. So now we know that the brand of my router is Huawei. So we can gather more information by opening this file in Wireshark, and we can kind of guess what computers are there and what operating systems they use. But this is not detailed enough. And the main problem with this is the fact that the network is using encryption. Now, in the next section, we're going to be talking about how to break this encryption. And once we do, you'll see how we can see the passwords, the usernames in plain text. And you'll also see how we can map all of the computers on the same network, gather detailed information about them, hack into them, and do some really, really cool stuff. Now, you should guess by everything that I said so far, if this network was an open network, if it was a network that does not use any passwords, then you would have been able to actually see all the URLs and everything that they do in here. But again, if you can connect to the network without a password, then you'll automatically be at the post connection section. And in that section, like I said, we're gonna talk about some really cool attacks that you can do once you have the password or once you can connect to the network. So don't worry about Wireshark for now. I just wanted to make sure that you understand why encryption is useful and why it's used and why we can't see much now because we don't know the key. We will talk about Wireshark and all of that later on in the next section. Now, before leaving this section and moving to the gaining access section where I'm going to teach you how to break the different encryptions and gain access to networks, I want to spend one more lecture talking about a really useful attack that still falls under the pre-connection attacks under this section. The attack that I want to talk about is the deauthentication attack. This attack allows us to disconnect any device from any network before connecting to any of these networks and without the need to know the password for the network. To do this, we're going to pretend to be the client that we want to disconnect by changing our MAC address to the MAC address of that client and tell the router that I want to disconnect from you. Then we're going to pretend to be the router, again by changing our MAC address to the router's MAC address, and tell the client that you requested to be disconnected, so I'm going to disconnect you. This will allow us to successfully disconnect or deauthenticate any client from any network. Now, we're actually not going to do this manually. We're going to use a tool called edureka to do that. From the previous lecture, we know that this MAC address right here belongs to an Apple computer, and like I said, this Apple computer is actually my computer right here. And as you can see, this host machine is connected to this network right here, which is the same as the one that you see in here, and it actually has internet access. So if I just look for test, you'll see that I'm connected and I can look for things, I can use Google, so I have a proper working internet connection. Now, we're going to come back here and we're going to use a tool called edureka to launch the deauthentication attack and disconnect this Mac computer from the internet. So we're going to type the name of the program, which is edureka. We're going to tell it that I want to run a deauthentication attack. Then I'm going to give it the number of deauthentication packets that I want to send. So I'm going to give it a really large number so that it keeps sending these packets to both the router and the target device. Therefore, I'll disconnect my target device for a very long period of time, and the only way to get it back to connect is to hit Ctrl+C and quit edureka. Next, I'm gonna give edureka the MAC address of my target network. So I'm gonna do -A and give it the MAC address, which I'm gonna copy from here. Then I'm gonna use -C to give it the MAC address of the client that I want to disconnect. And the client that I want to disconnect is this client right here, which is the Apple computer, like we said. So I'm gonna copy it and paste it here. If your target network runs on the 5 GHz frequency, then you'll have to add -D to the command in here. But my target, as you can see, it uses 2.4 GHz. Therefore, I don't need to do this. And I'm simply just gonna add my wireless card in monitor mode, which is Mon0. Now, it's very important to understand that this command will only disconnect the target client from the specified network. So if there are other networks that the target client can connect to, it will automatically connect to them. So in many cases, it might connect to the 5 GHz version of the network, or it might connect to a completely different network that it already knows the password to. And if it's a mobile device, it might even continue to have internet access through its mobile data plan. So it might seem like the attack did not work, but it actually worked, and the client just disconnected from this network and is using another network. To solve this, all you have to do is simply open up a new terminal window and run the exact same command, but this time target the new network that the client connected to. I actually covered that along with more advanced topics in my advanced network hacking course. Check out the bonus lecture, the last lecture of this course, for more information about my advanced network hacking course and all of the other courses that you can take along with this course. So a very simple command. We're typing areplay-ng. This is the name of the program that we're going to use. We're doing --dauth to tell areplay-ng that I want to run a deauthentication attack. I'm giving it a really large number of packets so that it keeps sending the deauthentication packets to both the router and the client and keep the client disconnected. I'm using -a to specify the MAC address of the target router or the target access point. Then I'm using -c to specify the MAC address of the client. Finally, I'm giving it mon0, which is the name of my wireless adapter in monitor mode. Now you can run this command like this, and in most cases it would work, but in very rare cases this command will fail unless aerodumpng is running against the target network. So what I'm going to do now is I'm going to go back to my first terminal in here, and I'm going to run aerodumpng using the command that we've seen before. And I don't want to write anything to a file, so I'm going to remove the write argument. So I'm just doing a normal aerodumpng command. I'm literally just giving it the BSS ID of my target network, and I'm giving it the target channel. And then I'm just going to hit enter. We've seen how to do this. We spent a full lecture on it. That's why I did it really quick. And then I'm going to go back to the command that we wrote so far, and I'm going to hit enter. Now, as you can see, areplay-ng, it's telling me that it's sending the deauthentication packets. And if we go back here and look up, you can see that I actually lost my connection and I'm trying to connect back. So obviously, if I try to look for anything, so let's say test2, you'll see I'll get stuck and nothing will load for me. So the only way for me to connect back is if I go back here, if I quit this by doing Ctrl+C, quit this again, and now my machine should be able to connect back and restore its connection. This is actually very handy in so many ways. It's very useful in social engineering cases where you could disconnect clients from the target network and then call the user and pretend to be a person from the IT department and ask them to install a virus or a backdoor, telling them that this would fix their issue. You could also create another fake access point and get them to connect to the fake access point and then start spying on them from that access point. And we'll see how to do that later on in the course. And you can also use this to capture the handshake, which is what happened in here actually. And this is vital when it comes to WPA cracking. And we'll talk about this once we get to the WPA cracking section. So, like I said, this is a small attack that can be used as a plugin to other attacks or to make other attacks possible.